हेलो एवरीवन। आज के इस सेशन में हम लोग पढ़ेंगे कि इंटरेक्शन ऑफ ईएमआर विद द अर्थ सरफेस फीचर. इन अवर लास्ट सेशन we studied about that how the EMR interacts with the atmosphere and what are the different processes that takes place when the EMR interacts with the earth surface, with the atmosphere or with the particles that are present in the atmosphere. As you can see the figure here are this figure shows various processes that takes place when the EMR interacts with the atmosphere as well as with the earth surface features. Transmission happens when the EMR interacts with atmosphere as well as when the EMR interacts with the earth surface features, whereas reflection only happens or only takes place when the EMR interacts with the earth surface. Absorption also takes place when the EMR interacts with the atmosphere as well as with the earth surface features, whereas scattering always takes place whenever the EMR interacts with the atmosphere. So it is clear from this figure that what are the processes which takes place in the remote sensing process. So now we will move on to the phenomena or the processes that takes place when the EMR interacts with the earth surface features. So first of all, the radiation which travels through the atmosphere only reaches the Earth's surface if it is transmitted. If the EMR is absorbed, then the energy is lost, whereas if the scattering takes place, the energy is diffused already in the atmosphere. Only the transmitted energy which is left reaches the Earth's surface and it interacts with the Earth's surface features. The transmission basically is the penetration of the materials or penetration of the atmospheric particles, and it reaches the earth surface and interacts with the earth surface features. When the EMR interacts with the earth surface features, three physical processes takes place. Those are reflection, absorption and transmission of radiation. As we have also seen that what is absorption? Absorption is basically the loss of energy to the particles. In other form, you can also see that absorption is the reduction in radiation intensity as its energy is converted on reaching an object on the Earth's surface. If the intensity of the radiation is changed or is converted into some other kind of energy, then it is said to be absorption. So absorption has two different definitions. You can look at absorption through these two different definitions. Now we will move on to what is reflection. Reflection is basically the returning or the throwback of the radiation which is incident upon the Earth's surface. Suppose an EMR is coming and interacting with the Earth's surface. Now, after interacting with the Earth's surface or any other Earth surface feature, the radiation is returned to the atmosphere. That process is known as reflection. Now we will discuss about transmission. That what is transmission? Transmission also happens in the atmosphere. As we have seen that transmission is the penetration of radiation through the particles. Transmission is basically the transfer of radiative energy from an object on the Earth's surface to the surrounding bodies. If the EMR interacts with any object and comes out from the other end of the object, then that process is known as transmission. All these three processes, absorption, reflection and transmission makes up radiative flux. Now we will discuss that what is radiative flux. Radiative flux is basically a sum total of absorbed energy, reflected energy and transmitted energy. So now we will see that all these processes, reflection, absorption and transmission, are each specific or are each particular to every Earth's surface feature. If the EMR is interacting with a tree on the Earth's surface, then the reflection, absorption and transmission rate of that EMR will be different than if the EMR is interacting with the water body. Every feature on the Earth's surface have different uh, rates of absorption, transmission and radiation. That is why absorption, transmission and reflection vary from one place to another or from one feature to another. Now we will discuss all these three processes in detail. First of all, we will move on to absorption. This figure here also shows us that what is reflection, absorption and transmission with the help of a figure. So in this you can see that EMR is coming in first part, it is interacting with the surface and then it is reflected back in another direction. That is the reflection process. In second part or in the middle part, you can see that the energy is coming and interacting with the black body, and then it is neither getting reflected or neither getting transmitted. The energy is lost here. That is why this process is known as absorption. In the third part, you can see that the EMR is interacting with the surface and it is coming back from the other end of the surface. That is known as transmission. Here, this figure also shows the radiative flux or the whole processes, reflection, transmission and absorption in one place. So now we will discuss about absorption. Basically, absorption, as I have discussed earlier, absorption is the process by which radiation is absorbed or the energy is lost, or you can say converted into another forms of energy such as heat energy or chemical energy. Now, absorption is wavelength dependent. What do we understand by wavelength dependent? As we have seen in electromagnetic spectrum that each energy form like X-rays, gamma rays, microwaves, infrared, visible, each have their own different wavelengths. So these wavelengths decide that how much absorption will be done if the EMR is interacting with a particular feature. So absorption of light occurs because of the incident light is transformed into the energy of motion of the atoms in the motion. Basically, this is a different form of describing the process of absorption. It says that absorption of light always happens when the incident light or when the EMR is transformed into some other kind of energy which is then utilized in the motion of atoms. So we can see that there are various phenomena that happen due to absorption. We can see that vegetation like forest, like grasslands, are conceived as in green color by our eyes. Why is it so? It is because only the green light is reflected from those vegetation. The blue and the red light is absorbed, and that is why we cannot see those spectrums of light. Clouds also absorb a little portion of visible light. And now we will see that what are the main constituents that absorb the light. The three main components or the constituents, as you can say, which absorbs the light in the atmosphere are ozone, carbon dioxide and water vapor. These three constituents absorbs the most of the radiation in our atmosphere. Now we will discuss about the process of transmission. As we have discussed that what is transmission. Transmission is the process by which incident radiation passes through matter without measurable accentuation. It means that when the material allows the incident ray or allows the EMR to pass through it without causing much difference, then that process is known as transmission. So it is similar to, as you can say, the substance through which the radiation is passing is basically transparent. as we can see in both directions from a transparent film or from a transparent surface. It is similar to that process. Transmission through material media of different densities, example air and water, causes radiation to be refracted or deflected from a straight line path with an accompanying change in its velocity and wavelength. Through this statement, I am trying to explain that if a EMR is entering into different medium with a different density from a particular medium with a particular density, the path and the velocity of that EMR changes. Like if an EMR is passing through the atmosphere, it is air, and then it interacts with the water, so the EMR will change its path and its velocity when it enters into the water. So in transmission, in different densities, EMR changes its path as well as its velocity. Now we will look into some figures that will help you to understand the processes more carefully. So this first diagram shows the process of absorption and transmission. Energy is coming as the bold arrow is showing the EMR, direction of the EMR, and the blue line, the blue block is showing that there is some kind of medium, air, water or any other kind of medium. Some of the energy is lost here, whereas some part of the energy comes from the another end of the particle. So energy which is lost is absorption, whereas energy which has penetrated the material is transmission. Now we will move on to reflection. That what do we understand by reflection? Basically, reflection is the throwback of the incident ray. Whenever an EMR interacts with a particular feature, some part of the EMR is thrown back to the atmosphere. That part is known as reflection. Whereas it is very important to learn that we can call any process a reflection only when the reflected angle and the incident angle are equal to each other. If they are not equal, then that process cannot be known as reflection. Reflection is a process in which energy is incident on the surface in such a way angle of incidence is equal to angle of reflection. When an electromagnetic energy is incident on the surface, it may get reflected or scattered depending upon the roughness of the surface relative to the wavelength of the incident energy. So, we can say that whenever the EMR interacts with any earth feature, the feature's roughness decides that whether the reflection will take place or whether the scattering will take place. Now, we will look into two ways in which reflection takes place. The two ways in which reflection takes place are specular reflection and diffused reflection. Now we will try to define and understand what is specular reflection. When the surface is smooth like mirror, we get a smooth reflection where all of the incident energy is reflected into one particular direction. This is known as specular reflection. Whenever we have a surface which is plain like mirror, then all the incident energy is reflected into only one direction, and hence the angle of incidence and the angle of reflection is equal to each other, and that type of reflection is known as specular reflection. Whereas in diffuse reflection, it happens when the surface with which the EMR is interacting is rough, and the incident energy, the incident ray, is not reflected back into one particular direction, whereas it is reflected back into different directions having different angle of reflectance. That is known as diffuse reflection. We will try to understand this difference between specular reflection and diffuse reflection with the help of a diagram. So, here are two diagrams. The first diagram explains that what is reflection, whereas the second diagram explains the difference between specular reflection and diffuse reflection. First of all, we will look into first diagram. Here you can see there is a surface which is colored in blue, is a plain mirror-like surface. An incident ray is coming and then it is getting reflected back to a certain direction. Here, the angle of incidence is equal to angle of reflection, and hence this process is known as reflection. Now we will move on to second figure. In second figure, there are two figures. First shows specular and second shows diffused. In a specular reflection figure, you can see that the incident ray is getting reflected back into one particular direction, and hence it is specular reflection. In the second figure, in the second part of the figure, you can say that incident ray is coming, but after interacting with the earth's surface features, it is getting reflected into different directions. That is why it is known as diffused reflection. Here also, in this figure, this figure will help you to understand specular reflection and diffuse reflection in a very detailed manner. Now, after discussing the interaction of EMR with the Earth's surface features and the processes which takes place after the interaction of EMR with the Earth's surface, we will move on to spectral response patterns. That what are spectral response pattern? Spectral response patterns are known by various names. Their other names are spectral signatures, spectral response curve, spectral curve, and so on. Now we will try to understand that what is response pattern and how do we create a spectral response pattern. First of all, we will try to understand the definition of a spectral response pattern. So, the magnitude of energy that an object reflects or emits across a range of wavelength is called spectral response pattern. Right? Earlier, we have discussed that each feature on the Earth's surface absorbs, transmits, and reflects energy in various different ways, and that becomes the basis for making of spectral response pattern. As we know that in electromagnetic spectrum, different kinds of energies are combined in an array uh, dependent upon their wavelengths. Either they can be in the form of small wavelength to long wavelength or from long wavelength to small wavelength. So whenever a particular feature like trees, like water bodies, like soil, like grass, gives the reflectance in any wavelength, that type of pattern is known as spectral response pattern. To be clear, we know that every feature on the Earth's surface creates a pattern, and that pattern is dependent upon the wavelength. So that is known as spectral response pattern. Each object on the Earth's surface has its own unique spectral properties: reflection, absorption, and radiation. These properties combine to produce a spectral signature, and it is these spectral signatures that can be used to distinguish one object from another. We always use spectral response curve or spectral response pattern to differentiate between two objects. Even two trees will have different response pattern if they belong to two different species. For example, in a satellite imagery, if you look at a broadleaf tree and at a conifer tree, then the spectral response pattern of both the trees will be somewhat different to each other, because both the trees have their unique spectral properties, their unique ability of reflecting, absorbing and radiating the energy. So now we will discuss that how do we create spectral signatures. To create spectral signatures, basically we take a 2D graph in which in y-axis we put reflectance and in x-axis we put wavelength in micrometers. So after creating this 2D graph, we point the reflectance of any particular feature in particular wavelength. Suppose water. For water, we know that water reflects most of its energy in blue wavelength. So the spectral response pattern of water will have its peak in the wavelength of blue spectrum. Whereas, as we know that vegetation or trees reflect most of the energy in NIR band. So the peak for vegetation or the peak for forest will be highest in the wavelength of near infrared. So now we will look into some spectral response patterns of some features that are present on the Earth's surface. In this first figure, you can see there are two curves for vegetation and water. You can see that the peak of the vegetation curve is around 0.7 to 0.8 micrometers. So, as we know that the vegetation or the forest reflects most of the energy in the NIR band, hence the peak of the vegetation is around 0.7 to 0.8 micrometers. In the next figure, there are some spectral response patterns which are showing spectral curves for vegetation, clear lake water, turbid lake water, dry soil and wet soil. Now in this figure, the spectral response patterns for soil, clear water, water with phytoplanktons, healthy vegetation and altered rocks is shown. So that is all for today's session. In next session, we will discuss about some new topics. So thank you for today.